Hey everyone, welcome back to another explainer from Forge College. So, last time we tackled the principles of transaction forwarding protocols, right? Well, today we're jumping right back into the Ethereum dev stacks and frameworks track. We're going to talk about securing smart contracts through metric literacy. Let's get straight into our introduction to test coverage metrics.
All right, let's just dive right into it. Have you ever stared at a beautifully glowing terminal completely filled with green passing tests, only to deploy your smart contract and watch it completely fail on some weird edge case? It is a brutally painful reality for developers. Here's the thing. A completely green test suite doesn't actually mean every conditional path or error case in your contract was exercised. Honestly, it might just mean you're incredibly good at testing the things you already know work.
So here's our blueprint for today. We're going to cover 1. The illusion of green tests. 2. The 3 coverage metrics. 3. Coverage as a map. 4. Reading a coverage report. And finally, number 5, actionable testing strategies. Let's go.
Section 1. The illusion of green tests.
Section 2. The 3 coverage metrics. Okay, so in our previous lessons, you learned that organizing tests with setup fixtures makes your iterations super fast, right? But structure alone just can't show you hidden vulnerabilities. For that, you literally need metric literacy. Under the hood, reporting tools are instrumenting your EVM bytecode to track execution. First up on the list is statement coverage. This basically measures whether each executable statement, like a discrete assignment, a math operation, or a function call, actually ran. Think of it as your absolute baseline check. It's really just asking, hey, did this specific unit of code do a thing at least once?
Next up is line coverage. This one reports whether source lines containing executable code ran during your tests. But wow, there is a massive blind spot here. Because Solidity compiles with optimizations, a single line might actually contain multiple statements. So if any part of that line executed, boom, the whole line gets marked green, which can completely overstate your actual coverage. And finally, we have the heavyweight, branch coverage. This measures whether the different possible outcomes of control flow decisions, like your if statements, while loops, and logical short circuits, were actually taken. Listen, this is your absolute most crucial metric for sniffing out missing failure paths and those sneaky untested permission checks. When you stack them all up side by side, it's super clear why no single metric tells the whole story. Imagine you've got an ERC20 transfer function with a require statement checking if the sender's balance is greater than the amount. If you write a test with a sufficient balance, you're going to get perfect statement and line coverage. Awesome, right? Well, not exactly. Because without a test that intentionally triggers a failure, your branch coverage is totally incomplete. You literally have to combine these views to find the real gaps in your error handling.
Section 3. Coverage as a map. To make all these abstract EVM bytecode concepts a bit more physical, try treating your code base like a giant geographic map. Your lines and statements, those are the landmarks in the cities scattered all across the map. Your branches, those if statements and requires, are the forks in the road. And your tests are the routes you literally ink out to explore this whole map. So line and statement coverage basically tell you which landmarks your routes pass through. But branch coverage, that tells you whether you actually explored both directions after you hit a fork.
And, as developers, we have this terrible, almost comical habit of building these massive, multi-lane, happy path highways. We drive our tests straight down the absolute easiest route because, well, it quickly confirms things work. We get high line coverage, everything looks great. But in the process, we completely ignore those unpaved, spooky dirt roads, the adversarial forks where all the complex conditional guards, and frankly, the absolute worst security vulnerabilities are hiding.
Section 4. Reading a coverage report.
In our advanced courses over at Forge College, we constantly see developers struggling to interpret uneven coverage reports. Let's say you test a brand new access control contract, right? The report pops up, 92% line coverage. Beautiful. You're probably tempted to pat yourself on the back, smash that merge button on the PR, and just assume the highway is fully paved. But wait, then you look at the branch coverage, 54% covered. Ouch, yeah, that hurts. When you dive in and inspect the annotated source, you see that the unexecuted branches are all hiding inside only owner-guarded administrative functions. So you visited the landmarks, sure, but you never actually tested what happens when some random user tries to hit the emergency pause. Those critical permission forks, entirely untested.
Section 5. Actionable testing strategies.
Okay, so now that we've found the unvisited forks, how do we actually target them? It really comes down to 3 easy steps. Step 1, open the annotated source from your testing tool and mark those uncovered lines as target landmarks.
Step 2, trace backwards to find the nearest fork that governs that route. And Step 3, write targeted, really short unit tests specifically designed to force traversal down that hidden path.
So how exactly do we force that traversal? Well, you have to be the adversary. You can change your test inputs to intentionally trigger those guards. You can mock external contracts to simulate sudden, unexpected failures. Or, you can use Foundry's awesome capabilities to simulate different message sender roles, like calling a protected function from a non-owner address and asserting the exact revert reason. Try testing the pause state versus the unpause state. The goal here is that these tests should be short, they should be hyper-focused, and they need to directly increase your branch coverage.
Now you might be wondering, what if a branch is deliberately unreachable? Because sometimes you do write defensive checks that, by design, just cannot be triggered under valid contract invariance. Look, if that's the case, please don't write 50 bizarre tests trying to reach it. Just annotate the code, leave a clear comment documenting the behavior, and genuinely consider whether an integration-level test or a formal proof is a better approach than just exhaustive blind testing.
If you take away absolutely nothing else from this explainer, let it be this. Percentages are signals, not proof. Coverage provides the diagnostic, but your tests are the prescription. The numbers just tell you where to look. It's the annotated source that tells you what you actually need to fix. Always prioritize small, focused tests over those massive sweeping ones that leave all those tricky forks completely unvisited.
I want to leave you with this somewhat provocative thought. Is your test suite a true, comprehensive map of your smart contract? Or is it really just a glossy tourist brochure highlighting only the sunny, happy paths? Think about that next time you sit down to write a test. Thank you so much for joining me for this explainer, and definitely be sure to visit forge.college to explore this and tons of other deep dive Web3 topics. Catch you next time.